are some bright lights right now in this audience. I mean, well, there's some bright lights in the audience. There's some bright lights shining at me as well. Welcome to this session on building scalable static sites with serverless. Does anybody listen to this podcast? No one? Anybody heard of the podcast? Couple. Okay, yeah, it's one of my favorite podcasts. It's Planet Money, and it's just like a 20-minute weekly kind of economics podcast, and they kind of ask kind of really interesting economic questions. And one of the questions they asked a while ago was that, well, sometimes President Trump tweets something negative about a company. And when he tweets something negative about a company or positive, he changes the stock price. So this is him tweeting something negative about Toyota Motors, and at that instant, the stock price reduced. So they asked themselves a question, well, what if you could try and build a trading bot based off of President Trump's tweets? And that's exactly what they did. They actually built one. It's called BOTUS, Bot of the United States. And you can actually follow it on Twitter as /BOTUS if you wanted to. So if he tweets something positive about a company, it would buy the stock. If he tweets something negative about a company, it would sell the stock. But the thing is, they're not an investment firm. They're a podcast. Okay, they put their own money into it. So what they eventually did, they shut it down. Okay, they each put up their own money, and they wanted to get it back out and start spending it on fun stuff like surfaces. And that's why I decided to create my own BOTUS. Okay, and that's what I did. I created a BOTUS application. It's got quite a lot going on with it. I'm not going to describe everything about the application, but there's a list of tweets. This is actually a video from quite a while ago. There's a list of tweets from the timeline, and you can see also it's also doing some interesting AI stuff, such as detecting the sentiment of the tweet. But that's not important for this talk. All that's important for this talk is there's a page with some dynamic data, such as tweets, and then there's, various things that's posting. You can't actually detect if that's positive or negative. And then, as well as a tweets page, we've got a trades page. So this is a list of all the trades that the bot made. So there's a bunch of selling. I think this was Mexican pesos, or buying Mexican pesos, and eventually selling all the Mexican pesos that it bought. And then there's also kind of a list of a portfolio, which is kind of the aggregate of all the trades. So you can see in total, borrowed $2,163, made all those trades, and made $83 profit. There we go. That's what I normally like to have, but I don't. Admittedly, $83 isn't a lot of money for the amount of time I put into the project, but I consider it a win compared with all of my other investment decisions I've made. The best money I ever made was in gold when I forgot I had some. But that's what in this talk, what we're really going to talk about is how to build an application like BOTUS. And I chose BOTUS. I have quite a few different applications that I work with. I chose BOTUS because it's quite a meaty application. There's quite a few different parts to it. And I didn't want this talk to just be a very, very simplified talk on static sites. I want to talk about the rest of the architecture which you need to build applications. So I'd say even as short as, I should say, 4 or 5 years ago, how we would architect an application like this is vastly different to how we'd architect it today. Okay? So typically, if we were building an application kind of 4 or 5 years, if I was building an application 4 or 5 years ago, I used to be a Django developer. People do web development today? Do you use who here uses server-side frameworks like ASP.NET, Django, Rails, things like that? And who here builds kind of websites using frameworks like Angular or React or Vue? Oh, interesting. Excellent. Right. So yeah, I mean, 5 years ago, I'd probably build this using Django or ASP.NET or something like that. It's all one monolithic piece of code. I'd probably have like a view layer, something that, the template rendering engine or something like that. You'd have a controller. I'm calling it an API. You might guess why. But there's also parts of this application that have got absolutely nothing to do with user interaction at all. So for instance, I've got a Twitter feed. There can be 0 users using the site. The Twitter feed still needs to run, okay? And I've also got a trading engine. And I think this is really common for a lot of the websites that we're building. I think a lot of talks that I go to, they talk about just that user interaction layer. They don't talk about, well, in reality, to build an application, you need all of these other things to work and to run in order for it to work. And so that's kind of what the topic of today is that this is how I would build an application like this using Django like 4 or 5 years ago. How would I build it today? And perhaps how would we build it in the next 2-3 years? And I think the word static sites is a really important word, and hopefully by the end of this talk, you'll understand why I think static sites are not just are the future of the web in so many different ways. Okay? So my name's Asim Hussain. You can find me on Jawache. You can find me on Twitter as Jawache. I have about, if 4 people follow me right now, I'll reach 9,000 followers. I can wait. No. So I also blog about Angular and JavaScript on my website, codecraft.tv, and I'm also what's called a cloud developer advocate at Microsoft. If you've never met one of us before, it's maybe understandable. There's not many of us. We're a new group inside Microsoft. We are the open source advocates, and the word advocate was chosen very, very specifically because an advocate is somebody who talks both ways. So I both advocate web on Azure to you, but I also advocate web back to the Azure teams. So if any of you want to speak to me afterwards, give me feedback. Any feedback you give to me goes directly into the product teams and to the product PM. So I'm like your line straight into them. So if you've got anything good you want to talk about, if you've got any good feedback for Azure, give it to me. If you've got any bad feedback for Azure, give it to my friend Burke in the front row. He's another cloud developer advocate. And yeah, sorry, if you want to go, you can find there's a bunch of us now. We cover all different open source technologies. I cover JavaScript. If you could hit that link at the bottom, you'll find that the rest of us, there's about 20 of us floating around Ignite right now. So if you want to go to one of our talks, that's pretty good. I'm also an instructor on a platform called Udemy. Does anybody here use Udemy? Does anybody know me from Udemy? Okay. Oh, one at the back, maybe. So Udemy added in automatic subtitling, I think about 6 or 7 months ago. And they correctly transcribed my name to awesome. So this talk is, my name's Awesome. And this talk is going to be very Asim. All right. Joke over. Let's get serious. What is a static site? Okay, the way I give presentations, the way I give talks, is I really try and break things down to the lowest level of understanding that kind of build people back up again to a different level of understanding. So I'm going to go deep into what is a static site. So this is kind of my personal blog. My personal blog is a static site. Is one flavor of a static site. There are many flavors of static sites. There's a standard one, so each and every time you navigate to a page, it's making a full page request to the server for some HTML, which is being returned back and it's being rendered on the screen, right? Absolute bog standard, basic, simple static site. We've been building sites like this for 25 years, maybe slightly longer, right? And how you kind of can detect a static site, what it kind of looks like on disk is like this. This is basically a part of the folder structure of my site. So you can see in different levels of a directory hierarchy, there are these index.html files, okay? So if you visit the home page, it will serve the home index.html. If you visited quickstart/activity, it would return the next index.html, right? And that's what you do with static sites. You essentially pre-render your application. You're pre-rendering it and storing them all as files on a disk and then serving those files. There's lots of different static site generators out there. So many, it's unbelievable. These are just some of the most popular ones that I've had some experience with, but there's loads and loads more. There's a great site out there if you want to find a list of all of them. I don't know if you know them or not. Static Gen has kind of a list of a lot of them. Gatsby is a very interesting one I've been using a lot recently. And kind of they're all written in different languages. Some of these are JavaScript, some of these are Ruby, some of these are Go, I think, one's Python, because you can build static site generators in multiple different languages, right? But the one problem that static sites have is they're read-only. They're read-only, right? Which has a lot of advantages, which I'm going to show you today. A lot of advantages in terms of performance. But one really big disadvantage is you don't get any user interaction. Because to get user interaction, you need to start adding functionality closer to the front end of your application, right? And what language can you build the front ends of your application is? What languages do all browsers use? They use JavaScripts. Okay, this is why I have some people question, why do we, when we talk about Angular and Vue and React, why are these the only web frameworks we're talking about these days, or other kind of JavaScript-based web frameworks? Because all the functionality is now moving towards a browser, and the only language every browser understands is JavaScript. Okay, that's it. This is why we're all talking about JavaScript these days. And with these frameworks, you can build other types of static sites, such as single-page applications. And that's kind of something I want to get across to a lot of you here. So probably a lot of you are building single-page applications or using single-page applications. And I think when I talk to a lot of people about single-page applications, half of them don't even realize that it's actually a static site. That's all you're building is a static site, okay? It's just, this is the output of an Angular build process. The folder just has one index.html file, that's it. Whether you have one URL or 10,000 URLs, you still just got one index.html file. And it's just a bunch of files on disk. It's a static site. The difference is that once this site gets loaded up in the browser, JavaScript takes over, and then it kind of adds a lot more interactivity to your applications. And that's kind of the real key takeaway. Did that flip around? Did it? Wow. So that's the key thing I wanted to take away here, which is that static sites, I consider them as kind of two different flavors of static sites. You've got your traditional multi-page sites. And for years, I've been being very clear when I use the word site. When I say website, I mean a read-only website. I've always had that distinction. And when I say web application, to me, that usually means you're interacting with a user. Okay? You're having some read-write functionality. So that's why I say static sites, kind of two flavors of them, multi-page sites and single-page applications. That's the way I would describe them. But how do you then move from dynamic to static? Okay, so dynamic would be how I would describe as building applications in ASP.NET or Django or Rails or whatever framework you people were using back in the day. How do we move from that over to a static site today? So this is kind of how, perhaps like 5 years ago, this is kind of how my architecture for my application might look like. I was building in Django in those days. And this could kind of be one monolithic application, right? And the question goes kind of, where do you host this application? Where do you put it? Okay? And so just to give a little bit of history into hosting, I'm going to break it all back down. I'll bring it back up all the end again. So back in the day, I'm old enough to remember this. Back in the day, all we used to have was on-premise. Okay? So that means that you owned the hardware. Okay? If the hard drive failed, it was on you to fix it. And then we got IaaS, infrastructure as a service, where you essentially rented the hardware and we kind of virtualized everything. So if the hardware failed, it was on us to fix it. But you're still responsible for installing the operating system and whatever web framework that you're using. Developers don't like that. So we built something else. We built something called PaaS, Platform as a Service, where we handle the hardware, we handle installing and maintaining the operating system. All you need to do is add the web framework. And that's actually what App Services is in Azure. It's our PaaS offering. It's our PaaS competitor offering compared to everybody else's, right? And this is where we would normally host an application like this back in the day. But now that we know we're building the front end of our application as an SPA or some other form of static site, the question then comes along, where do we host that? And the decision I see a lot of people making is just to host it on an app service. Right? Who here hosts their static sites on app service? I'm going to show you that there's a better way. Okay? A better way that's faster, that's cheaper. And I'm going to explain to you why it's faster and cheaper. They really discouraged me from using the word cheaper on talks, but I'm just going to go for it. There's a cheaper way. You don't have to spend as much money on Azure. But to understand that, we really have to kind of dig into kind of static versus dynamic kind of requests. Okay, so a static request is one that returns the same data for the same URL no matter what. So if you request a URL and you request the same URL, no matter what, it's going to return the same data. A dynamic request would be you request a URL, you request the same URL, different data. It's dynamic, right? Why is that important? It's important because it changes how you serve an application. Because when you've got a static site, and a static site means you're only using static requests, you need to use a service that is optimized for static requests. That's it. What is it doing? It's just reading a file from a disk and sending it back out. Those web servers are incredibly easy, incredibly performant, incredibly cheap, right? So on Azure, the equivalent service is Azure Storage. It's a web server. It's a web server, right? It's just a web server that doesn't know how to run code. It can just read a file from a disk and return it back out to you. Just as a quick side-by-side comparison, this is the same request to the same resource running on App Service and one running on Azure Storage. It's a completely basic bog standard test using Apache Bench, and I'm making 10,000 requests. Okay. Sold. You should all be sold by now, right? That should be it. That should be all you need. And the truth is, look, the truth is that I could probably tweak the app service settings. This was kind of the bog standard, out-of-the-box app service settings that I used for this test. But the point I'm trying to make is I didn't have to tweak anything for storage to work. Nothing at all. And I got that level of performance. I got that level of scalability, right? So that's what I'd recommend you do right now. So if you've got a static site, or remember, an SPA is still a static site, okay? An SPA is still a static site. Host it on Azure Storage. Now, we're all working in Azure, I presume, here, or not working, using Azure, I presume, here. It would be very confusing if you weren't using Azure and you're at this conference. But I presume you're all using Azure here, so you know there's many, many different ways of doing the same thing on Azure, right? The way I like is to use Visual Studio Code. Who uses Visual Studio Code? Love asking that question. So I use Visual Studio Code, and it's basically, you can now with Visual Studio Code just right-click on a folder, any folder, the output folder. If you see at the bottom, it's just got deploy to static website. There are other ones. Web app is app service. Static website is Azure Storage. And just the same way as you do that, please don't try and figure out what my subscription keys are. And that's it. That's all you need to do. And it's going to try and upload. Here it's asking me if I want to delete and redeploy. No. Didn't want to do that. But that's it. That's how simple it is just to deploy a static website on Azure. You can do, obviously, there's CLI commands you can use. You can use the Azure Storage Explorer. There's various different mechanisms. You can now pump it into Azure DevOps via a pipeline. There's a bunch of different things you can do. If you just want to do something quick and dirty, right-click deploy. I've got DevOps colleagues who would hate me for saying this, but right-click deploy is quite an interesting way. It's quite a quick way of at least trying it out, right? And the other reason why static websites are just so performant, okay, the last one I showed you was just that the technology to serve a static site is incredibly fast and incredibly easy. The other reason why static websites are so good for performance is in caching. Because if every single person is going to get the same data for every single, each URL, if one URL is going to return the same data for everybody, it's a prime candidate for caching, for heavy use of caching, okay? So the classic caching mechanism in the web is browser-based caching. So each of you individually in each of your browser instances has its own cache. And the second time you visit a site, it's going to read from the cache. But in reality, between your browser and the server, there's quite a few different nodes. There's way more than this, to be honest with you. There's quite a few different nodes. and steps to get there. We might already know about CDNs, content delivery networks. We usually do, because you usually have to pay extra for it, right? There's content delivery networks where you can cache your site for faster delivery to the end user, but it does cost you money. So you've got Azure CDN, for instance. But the interesting one I love, because not a lot of people know about this, we've also got proxy caches, okay? Proxy caches are being used less and less and less in the world, to be honest with you. More and more, they're still being used in countries where the internet infrastructure isn't as good. In the UK, we had proxy caches. Even 5 years ago, I was using proxy caches, but doesn't seem to be any anymore. So your ISP, the people you buy your internet from, will have their own caches distributed around the country. Because if everybody's looking at one website, the ISP doesn't want to pay the upstream costs to get that data, so they will cache the stuff locally. And a really interesting use case that happens, and I've done some amazing scalability exercises in this years and years ago. But if you cache your data and you are using it, and you're in a region that is using a proxy cache, when your user requests the data and it's cached on the proxy returns it. The important thing here is that you're not paying for the proxy. You don't even see the request hit your server. You probably never know it even happened, right? But somebody else is paying for your networking needs, right? So you can get an incredible amount of scalability and pay almost nothing for it, as long as your sites are static and you cache them correctly, okay? Free hosting. You didn't hear me say that, huh? Well, you have to use front-end systems like analytics, like Google Analytics or other ones like that captures users' clicks as they go through. In America, I don't think there's any proxy caches left in America. I have no idea. You probably have to speak to. Can we hold questions to the end? Cool. So you can do, there's loads of different ways, loads of different headers you can use to set caching correctly. I've got links at the end of this document that you can look at that teach you different mechanisms. This is the most important one, cache control public. Public is important because public means you can store this page at any public node on the internet, right? You don't want to do cache control public on a dynamic page like your logged in page for your profile. I've made this mistake in the past where I've cache control public someone's profile page, then other people have gone to their profile page and been returned the cache copy of somebody else's profile page, which has resulted in a lot of confusion, and I almost lost my job. So don't lose your jobs. Use cache control public only for static requests. And you can set other kind of properties which kind of set how long the cache you want to keep it stored in the caches. Max age only works in the browser. Max age works for kind of server-based caches out there. Again, just an amazingly easy, simple, cheap way to add incredible levels of performance to your applications, and you can only do it because you're a static site. That's it, right? Oh, and if you're using, there's various ways of setting up those headers inside Azure, using Azure Storage. With Azure Storage, as you upload, you can set properties on each and every asset that you're loading, where you can set the headers. Or if you're using Azure CDN, which I think is a better method, you can just set kind of regex path components and then set the caching rules as a rule like that. Because typically with our websites, you would typically have your cacheable stuff or your heavily cacheable stuff under a subfolder like static or assets or something like that. So this is a good way of being able to set all those headers just on those subfolders automatically. Or if you just want to cache all the JPEG files for a lot longer, you can set it that way. All right, so there's two reasons why static websites are just incredibly scalable, right? Use services that optimize to serve static websites, because that technology has been around for a long, long time, 25 years. We have optimized that to the max, okay? And use caching. Like anybody who's doing any performance on the internet knows, or any performance anywhere knows that caching is the key to getting any amount of performance anywhere. You've got to cache, okay? So use caching. All right. The title of this talk was Static Sites and Serverless something something. So who here has used serverless technology? Azure Functions? Same number of hands. Interesting. Who's using it in production right now? Okay, about 10% of the audience. I'm speaking to the other 90% of the audience right now, okay? So for the other 90% of the audience, I'm going to talk about what is serverless. I always like to give this definition because there's so many different people who have different definitions. The only thing you need to know is I have the right definition. Here we go. So this is an example of just kind of server load, or not server load, user load over time for your website. Okay, the Y is the load, and the X is time. So over time, users are kind of visiting your site, and the load, the demand on your site is going to go up and down. Back in the day, I remember being asked by management saying, look, let me know how many servers we're going to need for peak load for the next 6 months, because we need to buy those servers, and we need to install those servers in our data center. Okay? I see some gray hairs in the audience, so I think there's a couple of people here who have memories of the same thing. Maybe we still do it right now. So there we go. So this is what I used to do. I used to have to predict, which is usually just something like this, predict how many servers I needed, and then sometimes I got it right, sometimes I got it wrong. But the problem with this approach for a long time has been that you're essentially paying for all these servers that you're not using. That's usually what's happening. And in fact, I remember working at companies where we tried so many different ways to kind of leverage these servers for other functions while they're in idle time, but then that never really worked because then when you got peak load, something else was running on the server, and it was never really worked out as well as you wanted. But then kind of infrastructure as a service came along, and we enabled us to kind of scale up and scale down our servers programmatically, right? But we still had to solve this incredibly difficult problem, which is how many servers are we going to scale up by, and when, and why? You don't know whether this HTTP request is the last one, or there's going to be 10,000 more in 1 second. You have no idea at all. So how are you supposed to figure out how you're going to scale up and down? Okay? So what you tend to happen is maybe you'd scale up too much, and so you'd have these servers, again, that you're not paying for, or worse, you'll scale down too fast, and will give users bad performance, which you never, ever want, right, for our websites. What you really want is something like this. This is what you want. However many servers you need to service whatever the load that you have, and you only pay for whatever it is that you use. That's it. That's the definition of serverless. For me, it's actually not. It's not a certain type of architecture. It's not a certain type of technology. It's just how do you charge for a product? It's a primary way I would describe something as serverless. And we charge for our service technology, but you only pay for actual usage. If you had 0 hits, you pay 0. That's it. You never have to sit there and predict how much load your server is going to have in the future, right? And also, underneath is auto-scaling. You, again, never have to think of. Okay? If it's got both of these properties, then something in my mind is serverless, right? So that broadens the Venn diagram of what is serverless. Okay, quiz time. I usually have quizzes. There's no prize. Okay, so quiz. Given that question given that definition I just had right now, is Azure Storage serverless? Put your hands up if you think Azure Storage is serverless. Okay, 20%. Oh, that might be a hint. Put your hands up if you think Azure Storage isn't serverless. 3. Maybe you're right. In my definition, I always say is if it looks like a duck, if it quacks like a duck, if it tastes like a duck, it's a duck, right? So I think that Azure Storage, if you use 0, you pay 0, okay? Underneath, it's auto-scaling. Of course it's auto-scaling. Of course it's auto-scaling, right? You just never think about it. We never ask you, oh, when you want to put 5 files on the storage, oh, how many servers do you want to service those 5 files? No, you never ask, right? Underneath, it auto-scales for you. So I argue that Azure Storage is serverless, right? That's kind of the bombshell I give people. So if Azure Storage is serverless, if the best way to deploy your static site is on Azure Storage, then your static site hosting is serverless. Right? That's one of the reasons we like static site hosting, because you don't have to think about it. You just upload something and you're done. That's one of the beauties of it. And that's why I think, that's why this talk is kind of probably making a bit more sense. I think static sites and serverless is this beautiful combination of technologies that work really, really well together. Because if you're hosting a static site properly, you're hosting it in a serverless environment. So what you really want to do is, can you try and make the rest of your application serverless as well, okay, and get the rest of the benefits of the rest of your application. So this is it. So we've got kind of our SPA. It's sitting on storage. Its storage is serverless. So then the question is, can we make, let's have a look at the API. Can we make our API running on a serverless environment as well? Okay, same as our SPA. And you can, because there are other serverless technologies out there. FAS, functions as a service. Okay, things are going to start coming together now. Yeah, I broke you apart, bringing you back together now. FAS. The story didn't end at PaaS. Okay, the story didn't end up on PaaSes. What we realized, what people wanted, is that within a framework, you just have lots of functions. Functions are executed when you hit a HTTP endpoint. That's all that's going on with a web framework. Think about it. What else is it doing? It's calling a function when you make a HTTP request. That's it. So let's abstract that away into FAS, functions as a service, where we look after the hardware, we look after the operating system, we even look after the web framework. All you have to do is look after that one function body. That's it. That's FAS. And in Azure, it's Azure Functions. It's charged by gigabyte seconds plus execution, so we don't charge by traditional measures of load. It's kind of a volumetric approach to your compute. It does have limitations. It's limited to 5 minutes, so we unceremoniously kill your process after 5 minutes if it's taking too long, so don't take too long. And it's stateless, ish. I mean, it's kind of like a temp folder. If you might have it, you might not, but don't rely on it. Again, many different ways to work with Azure Functions. My favorite way is Visual Studio Code, as you might already have gathered. And it's really, really easy to work with functions with VS Code. So this is the Functions plugin. I've created a function application. I'm creating a HTTP trigger, give it whatever name I want. And it's created some stub code. I can just drop a breakpoint in, press F5, and it's running locally on my computer. Okay. One of the real, and I don't think we do a really good job of talking about this, to be honest with you, but I think one of the most amazing features of Azure Functions is the fact that the runtime is locally on your computer. When you look at the competitors out there, it's not. Whereas locally on your computer means you can debug and run locally. I couldn't code if I couldn't debug and run locally, right? So this is one of the most powerful features of Azure Functions. One of the reasons I think, I'm obviously biased, but I think it's the best serverless platform out there because of this reason, right? So that's what I would do. I would say basically take my API code, okay, put it in an Azure function, run it that way. But then we've kind of got these other things as well. I've got this Twitter feed and this trading engine. I could, in fact, run that as an Azure function as well. I could do that. But the problem here is that, for instance, I've got a trading engine, and we've kind of got this 5-minute hard cutoff point. I don't want to be in the middle of a trade and my application disappears. What do I do? So Azure Functions probably isn't the best place for running code like that. What you need is to think about a concept called orchestration. Okay? So something needs to run and look after your functions, right? If you think about it, the API is being orchestrated by the browser, right? The browser's calling the API. If the API fails, you might have retry logic in the browser. Okay? The user might click a button again. Everything has orchestration, okay? So we need some sort of orchestration for the Twitter feed and the engine. So it needs to orchestrate something, you need to be long running, Okay, you can't just be shut off after 5 minutes. It needs to be long running. So a common pattern I see, again, is you kind of have these people who half gone serverless and half kind of one foot in each land, right? One in app service, one in serverless land, and you're staying there for quite a while. Because app service can stay up forever, right? Only shuts down when you shut it down. But again, there's better ways. And the way I like to code up a lot of this stuff these days is with logic apps. Does anybody use logic apps? A few. Almost feels like a different set of people than the people who put functions up. Who uses functions and logic apps? Okay, 5 people. Okay, fantastic. So logic apps are fantastic coding visual coding workflows. Okay? So if you've never used them, it's kind of like IFTT or Zapier, but much, much lower level. So you can see here, you can have different connectors. I've got a connector when a tweet comes in, so that will trigger the workflow. This is doing other AI things, so it's calling kind of sentiment analysis APIs from the Azure Cognitive Services and enriching this message as it goes along. If you look very closely at the bottom there, you can see it's got some sort of control flow functionality as well, conditionals, etc. So it is actually very, very powerful what you can do with Azure Functions. I love them. I can't believe people aren't using them more. And then at the end, what I'm doing here is I'm actually connecting the whole thing up to that the trading engine one here. This is a very simple example. You can do other things like kind of retry logic for your Azure function, things like that. So they're great ways of orchestrating other parts of your application. And again, you're charged by number of executions. So if you execute 0, you charge 0. It runs on servers, it's code. Well, you never have to think about that, right? So logic apps is again serverless. It's another serverless technology that you can work with, right? And it kind of runs limited to 90 days. So although hopefully you don't have something that's running for 90 days. I don't know, maybe you do. But runs limited to 90 days, so it has like a longer, state lasts for a lot longer. And that's basically how I would architect the final different parts of our application. So I'd take the Twitter feed itself is kind of running as an as a logic app, so it can orchestrate the rest of my application. And the trading engine itself is again another Azure function. Okay? Then you can finally get rid of your app service, and every single part of your application is now running serverless. Okay? Your web app is a static site. For me, it was an SPA, a static site. And the functionality, your API is now Azure Functions. And things are orchestrating other parts of your application which are kind of not driven by user interaction. You can perhaps implement using other types of functions as well, because functions you can trigger from as timers, or when somebody saves something to a storage account, anything, it can be trigger a function. Or you can do it as an Azure Logic app as well. So in summary, SPAs are static. Okay? SPAs are just another flavor of a static site. Isomorphic, we've got stuff coming in the future, right? There's kind of just other flavors of static sites. All we're going to be talking about in the future is static sites, because when we say a static site, I think what we're really saying is the functionality has moved from the server side to the front end. So the server side is therefore just a static set of assets. The key functionality is now your web app, your JavaScript web app. So if it's static, we can therefore use heavy caching to get increased performance. And we can serve using Azure Storage as well, because again, if it's static, you need to use something that's optimized for static assets. Storage is serverless. Blew your mind on that one, pretty certain. So you might as well make the rest of your application serverless as well, get all the rest of those advantages. So use a FAS like Azure Functions for your API, and orchestrate with logic apps. And if I had more time, I would talk about durable functions. But I did have time, but I didn't put it in the slides. But have a look at durable functions. Have a look at that. They're another amazing feature of Azure Functions. I still believe right now we're still the only people with anything like durable functions. Durable functions let you run functions that elapse longer than 5 minutes, but the runtime, they do that by dehydrating out of memory, so you're not paying for it, and then rehydrating back in again, right? So a really amazing feature that only we have. If you want next steps, what you should take a look at, if you really seriously want to start taking a look at how to do static sites and serverless on Azure, my colleague Anthony Chu has a fantastic tutorial on the docs website. So if you take a snapshot of that link at the bottom, it will take you to it. And it takes you everything you need to do to build to deploy a static site on Azure, and also an example of how to use Azure functions with it. This is okay. We're launching in Ignite MS Learn, okay, Microsoft Learn platform. This is moving to Microsoft Learn. So double check if you're watching the video later on. Maybe just have a look at MS Learn to see if this has been migrated over to there. But right now, this is still to be found in this link. So it's a great little link to go to. That's it. Thank you very much for your time. Again, if you want to follow me on Twitter, Joy had 4 people to get to 9,000. I made it. Woo! Okay, thank you. We've got some time for questions. I think you've got to stand up to the microphone. So it's recorded.
First off, is this recorded? And I guess you answered that, so it's a video. And where can you get that?
So it'll be available via, is it Channel 9? I can't remember what the exact, it will be available via, I think, the Channel 9 site later on. I think that's what was available. Just keep a note of the breakout number for this session, and you'll be able to find the video. It's linked by the breakout, by the session ID number, the BRK.
So right on the app, you can do that, right?
Yeah, you can do that. Yeah, you can remember.
Very good, very good. So with functions, can you set up your own firewalls, incoming ports, that kind of thing?
Oh, that's a good question. I've never tried that. Functions typically are with HTTP endpoints.
Right.
I think I showed how to create an anonymous one, which was so not good. It's like completely anonymous to the world. Anybody can access it. Right. We can also set up ones where you have to specify a code, a secret key, in order to get access to it, or you get kind of a 403. You get permission denied error. Okay. Yeah.
Okay. Very good. And not to hog this thing, but just a couple others. Authentication, authorization. How do you do that through?
They're not built in to Azure functions, so you do have to implement those kind of things yourself. Okay. I think my colleague Brian Clark has come. I think he's coming up with, or he's about to come up with a blog article on how to do that, or a good way how to do that inside Node. Is that your framework?
Yeah, exactly.
Yeah, inside Node.
Very good, very good. And one last one, orchestrations, can you customize them?
Customize them how?
So if you want to talk to WebSockets, different WebSockets through different sites, that kind of thing, perhaps webhooks, different webhooks.
You can customize them many different ways. WebSockets is a tough one because we don't really have support for that. We are getting support with SignalR, but I'm not so knowledgeable on our connection. Again, Anthony Chu, who's gone from the screen, he's the guy. In fact, he's doing some talks here about SignalR as well. That's a way to do kind of WebSocket integration. They are incredibly customizable. So a Logic app, you can do a lot with a Logic app. If you go through it, there's so much you can do. And if you can't do what you need to do with a Logic app, durable functions is the way to go. Right? So that allows durable functions just code. And if you can do anything in code.
They go hand in hand, really. Is it?
I think they go hand in hand. I personally think it's kind of quite a nice move from each other. Durable functions, you can do a lot more with durable functions than you can do. It's not like one leads on from the other. It's kind of the sets overlap, put it that way. Yeah.
Very good. Well, thanks very much. Appreciate it.
Can you proxy cache HTTPS requests?
Oh, I don't know. I don't think you can, actually. That's a good point. That's a very good point, actually. I don't know. I'd guess not, because that would... Or would it? No, great question. Great question. I'll have to find out. Yeah. Other question? Oh.
When you have a CMS, how do you break out your static versus your dynamic? and you only have one platform you're using?
Yeah, it's a good question, right? So yeah, because that's if you're building a single-page application. Because a single-page application enforces a type of integration between, an API type of integration between your front end and your back end. And the only real way you've got to do it is, well, there are some, the official way you want to do it is you want to start breaking out your CMS and add an API, and then release a new application which kind of talks to the API. But quite often we're working with a lot of applications out there that are huge, right? Just saying, oh yeah, just convert everything to an API and build a new front end, done. It's hard, right? Because you've got a big legacy application. I actually talk about one method which people, I think I'm a bit crazy talking about it, to be honest with you, but iframes, right? So I have a method of migrating an Angular application from an old Angular to a new Angular application. If you go to my blog, codecroft.tv, and you go in the blog section, you actually see something in there. And I propose a method where your new SPA is here, and you iframe in your old application. And you can imagine as you basically have to migrate kind of one tab, I don't know how your application is, one tab at a time. And when that tab, you've migrated it to an API with an SPA, then it's not being iframed in anymore. It's just as a normal tab. If you go into a tab which you haven't migrated, that just does an ugly iframe in. You don't want your application to stay like that for years, but it does give you a way of kind of iteratively moving forward, which kind of works with legacy applications. Yeah. Legacy. Sorry to call it legacy. Any other questions?
Hi there.
Oh.
I'm wondering about how you'd apply a custom domain to a storage account and SSL.
Okay, so both those things, they're all being added. They're all being added. So right now you can add a custom domain. You can add SSL through CDN. Okay, so that's the only way you can do it right now. This area we're working on it a lot because I'm here and I want to feed your stuff back to them. So we're working on it a lot. The one downside we have right now is that you can only do, and it's with both storage and CDN, you can't have Apex domains. So it's got to be, you know, www dot something like that. But again, we're moving towards a model where you don't even have to have that as well. But that's going to require some other architectural changes to the application. But yeah, so you can do both those. You might have to do it via CDN. Yeah.
This is the first time I've seen logic apps, so I apologize if this is an obvious question, but can you assign like the role-based access controls to it, like a role to a logic app? And then also, what kind of visibility do I get into what's going on via like Azure Monitor, or Log Analytics, or Application Insights?
Great questions, and I don't know the answer to either one actually. But yeah, connect with me on Twitter because I'll please connect with me on Twitter. Connect with me on Twitter.
I'm one of your 9002.
My 9002. DM me, and I will put you in contact with a PM, and he can answer that question for you.
Hey, I've got one quick one. So my company, we have a 20-year-old application that's been written largely in classic ASP, and we're trying to break things away and get them onto Azure for a whole long list of reasons. And I came to this session specifically because I think our static content is a great candidate.
Okay.
But right now we leverage on-prem static site with CDN across the globe. What are some of the, from your perspective, like immediate benefits of going off our on-prem static site to serverless, even if we are already leveraging CDN?
Oh, so describe to me. So your static, like your website is a static site right now?
No, we have a whole giant web application written, like I said, in classic code, but we do have a laundry list of static assets, of course, that we serve up with our site.
Like the JavaScript files, the CSS, these things like that?
Yeah, a lot of our CSS content, all of our imagery, and all that stuff, yeah.
So for those things, you're using the Azure CDN, or Azure Storage with the CDN?
Using a CDN.
A CDN. A CDN. So we were asking then, what is an advantage to move the rest of it on? I mean,
I mean, is there like a performance advantage to moving to a serverless model, also utilizing the CDN, or are there?
In general, the serverless model is a large part of it is about scalability. You know, not having, and also they call it no ops. I don't think that's a fair term, but the reduced amount of developer time that's spent managing the infrastructure of the application, right?
For the record, I work in operations, so.
Okay, right, okay. So you'd be out of a job. No, that's not true. But yeah, I mean, it's difficult to know without knowing more about your architecture, but I think there are generally the benefits are from not having to put not having to spend as much time in your infrastructure of your application, not having to really worry about scalability because it just scales out for you automatically. Cost-wise, I mean, I think pound for pound, we're probably cheaper because you don't have to worry if you don't want to worry about the scalability. Because one of the advantages is that at the end of the day, we're trying to solve that incredibly hard scalability problem. We're trying to solve it, right? We get it wrong all the time as well. But the difference is when we get it wrong, we don't charge you. Right? That's the difference. Because we're Microsoft, we can kind of combine those costs with other things. Yeah. When you get it wrong, it costs you money.
Yeah.
Right? So I think that's kind of, maybe I think one of our advantages is just the fact that we're so big and we've got all the things running inside them, we can interleave the costs with each other, put it that way. Does that make sense?
All right, cool, thanks.
We're good. Thank you very much.